So this is the first video I've done for pre-calc, so we're going to see how this goes. But these are the notes for evaluating logarithms without a calculator. Now if you remember, the first day, the introduction to logarithms, we said logarithms are exponents. So when we look to see what is log base x of y asking for, it's asking for, or what it's essentially asking for is what exponent does x need to equal y? And really, for any logarithm, what does the base need, what exponent does that base need to equal your argument? Now remember, it's always exponents. It's not what can you multiply, what can you add or subtract or divide. It's always exponents. So if we're looking at this first example down here, this is asking us 4 to what power equals 4? Well, in this case, it's just 1. That's your answer. 4 to the first would give you 4. Now these other ones over here we're going to come back to in just a moment. So on our next slide, there are 3 examples here. So log base 3 of 9. So this is asking what exponent does 3 need to equal 9? Well, we know that's just 2. But you could write this out if you want. 3 to the what equals 9. Okay? Same thing on the next one. What exponent does 2 need to equal 16? Well, that would be 4, because 2 to the 4th equals 16. Now the last one is a little bit tricky because now we have a fraction. But think of how exponents work. Remember, we're always dealing with exponents. So 1/5 I could rewrite as 5 to the negative first, because that's how negative exponents work. So this could be log base 5 of 5 to the negative 1. What does that equal? Well, that equals negative 1, because 5 to what equals 5 to the negative 1. Well, that what is negative 1. Now, you only have to worry about one special case, and we're going to go back to the first slide to talk about that special case. And it's over here in the corner when your argument equals 1. Anytime your argument equals 1, your answer is 0. Because 5 to what power equals 1? Or, in this case, 345 to what power equals 1? Well, if 0 is your exponent, it always equals 1. It doesn't matter if your base is 5 or if it's 345. 5 or any number to the 0 power equals 1. So that's really the only special case. And it's not really even a special case because it still follows the same rules as what we were doing. Just remember, if you ever have 1 as an argument, your answer is always going to be 0. So here we have our 2 logs that you'll find on the calculator, ln and log. Well, we can rewrite them using the bases that we know from yesterday. So ln of e is really log base e of e to the 3rd. So that's going to be 3. Because what exponent does this e need to equal e cubed? Well, it needs a 3. Now if you have a number out front like this one, we'll just say 9 times log base e of e to the 4th, and this whole logarithm equals 4, so 9 times 4 equals 36. Now what I'm going to say next is not really mathematical, okay? But essentially, whenever you have natural log and e together, so ln of e, anytime you see ln e together, they essentially go away. Now again, that go away is not a mathematical term. They don't cancel, they don't divide out. They just go away because that's the way we would rewrite it, log base e of e. So if I see this ln of e together, it really just goes away and you're left with 3. Same thing over here. The ln of e just goes away and you're left with 4. Now, on the bottom here, we're going to write these as log base 10. So log base 10 of 1,000. Well, remember, what exponent do you need? Not what you're going to multiply by, but what exponent? And the exponent I need is 3, because 10 cubed equals 1,000. And for this next one, now, we have a decimal. So first thing I'm going to do is still rewrite it with base 10. Now, that decimal is 1/100th. So log base 10 of 1 over 100. Now, log base 10, 100 I can write as 10 squared. And then since it's in a fraction, log base 10 of 10 to the negative 2. So this equals negative 2. All right? So, if we were in class right now, what I would ask you to do is try the next 4. So if you want to pause the video for a second and then go ahead and try to do those 4, that's fine. But that's what I would ask you to do in class. So go ahead and try these 4, and then I am going to write the answers down. So if you want to pause the video now, try them, and then you'll be able to see the answers. So log base 2 of 8 is 3. Log base 3 of 81 is 4, and you should know that. And I'll write on the board next week all of the exponents that you should know, but 3 to the 4th is 81. The one up here, log base 7 of 1/49th, is going to be negative 2. And log of 0.1 is going to be negative 1. So for the next slide, I want you to do the same thing. If we were in class, I would ask you to do these on your own. So why don't you pause the video, try to do those 4, and then you can play it again and see the answers. So the answer to the first one here should be negative 2. The answer to this one down here, negative 2. Now remember, this is times log base e of e to the 9th. So it's negative 2 times 9. So it'll be negative 18. 2 to the 5th is equal to 32. And now this last one was a little bit different. So first I'm going to write in my base. So log base 10. Now 100 I can rewrite as 10 squared. So 10 squared is equal to 100. I haven't changed anything. Now remember, when you take an exponent and raise it to another exponent, you multiply them. So this becomes log base 10 of 10 to the 8th. So this is going to equal 8. Now, the last type of examples here deal with roots. And it's really no different. It's exactly the same as everything we've been doing. So I'll leave that 10 out front. Log base 2 of 8 to the 1/2, because square root is equal to an exponent of 1/2. Now, I know that 8 is 2 cubed. So I'm doing this exactly how we did the last one, with 100 to the 4th. So now I can multiply those two exponents together. So log base 2 of 2 to the 3/2. So now 10 times 3/2 is 15. And we're going to do this bottom one the same way, only now it's a cubed root instead of a square root. But still, we'll leave the 4 out front. Log base 6 of 36 to the 1/3. Now, that 36 I can rewrite as 6 squared. So 4 times log base 6 of 6 to the 1/3. Oh, I'm sorry, I didn't multiply. 2/3. So 4 times 2/3 is 8/3. So for this last slide, again, if you want to pause it and try these 2 on your own, go ahead and do that now. But the answers are, so 12 times log base e of e to the 1/2 equals 12 times 1/2, which is 6. And then the last one here will be 6 times log base 3 of 27 to the 1/4. Then 27 is 3 cubed. So that's 3 to the 3/4. So 6 times 3/4 would be 18/4, which reduces to 9/2. Now remember, this test is going to be half calculator, half no calculator. Obviously, all of these questions would be without a calculator. So whenever you're doing your homework or any of these problems, you should be doing them without a calculator. Now, if you look at the homework, the first page, and these ones over on the left, all of these, the difficulty is like the ones that we were doing at the beginning. Okay, and if it says to skip 4 and 7, but if you want to try them, those would be ones that you would like see as bonus questions maybe. And then the second page, 19 through 28, these ones are the ones that are a little bit more difficult, that have the square roots in them, or the cubed roots, or whatever kind of roots. So the difficulty on the second page is a little bit harder. Okay? And if you have any questions, of course, I'll be back next week. And you could watch this video even though you took the notes, or you could watch it again and again, whatever you need. But any questions or anything you need, just don't hesitate to ask.